Hey everyone, Aurora here with Supercharged Science, and today we're going to talk about polymers in our chemistry class today. We're going to make bouncy balls. Isn't that cool? So you don't actually have to make them round. They could be squares, they could be, like cubes. They could be pyramids, they could be dodecahedrons, and they really do bounce. I'm going to lose this if I bounce it though, because I've got a bunch of stuff like here that you probably don't see. So while people are jumping on, because I know we are just now starting, so happy Wednesday. We are doing chemistry today. This is our third class. If you've already done the first couple of classes, you are in good shape. We are ready to go with a third one. If this is your first time with us, no problem. We're going to take it from the top. We are going to do a little bit of chemistry background, foundation, fundamentals, and then I'm going to show you how you can make your own bouncy ball using just 2 ingredients. Now, if you don't have any materials, don't panic. It's actually better if you don't have materials. That way you can watch me and not get sidetracked. And then at the end, you're like, oh, okay, I know what I need. I know what I can do. This is the quantity I want, that sort of thing. Not necessarily so much for chemistry, but this is especially true with like robotics and electronics, and when you're building catapults and all kinds of really cool things like hovercraft and stuff, because you don't have to use exactly what I'm showing you. You can watch the experiment, and then when you're done, you're like, oh, you know what? I don't have popsicle sticks, but I got these wood planks, no problem. Or I don't have a rubber band, but I've got this bike inner tube. That's totally fine. Now with chemistry, you are not going to want to substitute things because often the chemicals aren't pure. So if you're thinking, oh, I could use, dish soap for this. Well, dish soap is also going to have some other things in it that may or may not be good for your experiment. So with the exception of chemistry, you can substitute. For chemistry, no substitutes. Make sense? Okay, notice what's on my hands. So anytime you do chemistry, you're going to make sure you've got your goggles on your face, which I have here, and you've got gloves on your hands, and we are ready to get started. Okay, now for those of you who are just joining me for the first time, my name's Aurora with Supercharged Science, and we are going to be doing this free class in chemistry. We'll be together for about 30 minutes, and when you're done, there will be more chemistry that you can do. Now, if you've already participated before, you know how this works. If you missed any of my classes, maybe you didn't make Mondays, but you got Tuesdays, just go to our video archive on Facebook, and Facebook automatically will archive all of our Facebook Lives. If you have a question at all, anytime during the class, type it in. You see the comments? Make sure you're staying on topic and relative to what we're doing. If you're starting to spin off and chat with other people, you're actually going to get kicked off our site permanently. So please don't do that. Keep it on topic, keep it relevant. We are kid friendly and kid safe here, so we are pretty strict about that. So I am really excited. If you'd like a shout out, just tell me your name and where you're from. If you're outside the United States, you can also include your country, and I will say hello. We're also monitoring emails, so if you are sending an email, it's aurora@superchargedscience.com. And we are going to get started. Chemistry, oh, I've got the wrong link at the bottom. Do you see the link at the bottom here? Let me fix that just really quick here. I've actually put together a really big class for us to do together tomorrow. And this class is going to be a lot longer. It's going to be, probably closer to 90 minutes. It has worksheets, vocabularies. It's like a full lesson packet. So when you sign up, so tomorrow I'm not going to be on Facebook Live. I'm going to be doing a really big class, and we have thousands of people already registered for this one. So we can't do that on Facebook Live because I need to email you stuff. So make sure you sign up using this link here, and you'll be good to go for tomorrow. Okay, so we have a few people. My mom is getting paper so I can make notes. Yes, if you have no materials, grab a sheet of paper, grab a pencil, and just take notes as we go along on the things that you're like, wow, that's cool. So it's really easy. There's nothing to collect. There's no homework. Nothing is a test. This is just for you so you can keep learning as we go. Okay, you guys ready? So we have hello from Alberta, Canada. Hello, my best friend lives in Edmonton. So hello. Let's see. We have Emma from Oregon. Hello, and we have the Patton kids in Idaho. Good morning. We have Grace from Mississippi, and we have Angie from a homeschool teacher with 3 students from North Carolina. Hello. Okay, you guys ready to get started? All right, let's get going. So you're going to go ahead and watch me first. We're going to talk a little bit about chemistry, and then I'm going to show you some really cool stuff I've got down here. Okay, so chemistry. Remember we talked about that before? What was chemistry? Do you remember? What's your best guess? What is chemistry? Oh, I got it capitalized here too. Okay, you're telling me what chemistry is. You can type it in the box while I am fixing the typo I have here. For those of you who are still looking at the link, /lowercase chemistry. Okay, chemistry. So what is it? Is it the study of matter, the study of energy, the study of how stuff interacts with each other? What is it? So let's see if we can explore this idea first, and you can get some ideas as to what chemistry really is. Now, we talked about some of these things last week. Wait a minute, where is my slide changer? There we go. All right, how many of these things do you already know? Now, we covered a lot. Actually, we covered all of these already. So real quick, what's an atom? Say it out loud. Just pretend I can totally hear you right now, and you are shouting back the answers towards me. Just tell me, what's an atom? That's right, it's the smallest bit of stable matter. There are other things that are smaller, but they're not stable. And by stable, we mean it doesn't break apart when you put it on a shelf. Like if you stick a neutron on its shelf, it'll actually turn into a proton after about 15 minutes. So that's not what we're talking about. Okay, smallest bit of stable matter. Good, element. And how's that different from an atom? Element is a pure substance, all one bite. So it's all copper, all zinc, all oxygen, all hydrogen, one thing. Got it? Okay, good. Molecule, remember what that is? I'll give you a hint, dihydrogen monoxide. Great way to freak your parents out, right? Water, H2O, dihydrogen monoxide. When you start putting those atoms together, then they start forming molecules. Carbon dioxide, hydrogen peroxide, H2O2. So you start putting those Lego pieces together. Remember we talked about Legos, how there's like a lot of different kinds of Legos, and each different Lego is different, right? You can have a yellow cube, and you can have a something that looks like a trapezoid that's red, and a blue rectangle. They all look different. So atoms look different. The hydrogen, the oxygen, the carbon, they all look different, and you can put them together into different ways. The way you can, what can you make with Legos? Tell me, what have you made with Legos before? Or if you can imagine making things with Legos. You can make anything, right? You can make Swiss cheese. You can make a house, a car, a robot, a ladder, anything, right? Same thing with molecules. I can put all those molecules together and make different things. That, like the chair you're sitting on, the air you're breathing. All of those are formed with molecules. Okay, matter. Matter, what is it? Any ideas? So matter is anything that takes up space. Could be air, could be kittens, could be your left nostril. Anything that takes up space, that's what matter is. Good. States. What are the states of matter? We talked about them before. Say them out loud. Solid, liquid, and gas. Anything else? That's right. We have plasma. It's just what happens with gas when what happens when you put so much energy into the gas that it starts knocking electrons off of the atoms, and that makes the gas have this strange electrical charge property, which is why it glows. So we call that fourth state of matter. That would be plasma. And then we also talked about stuff what happens when you get clouds of gases really, really cold. Okay, great. So you're doing great. Homogeneous. That means the same. So a homogeneous mixture, this is all iodine, this is all salt water, whatever it is, but it's all one thing. So it doesn't matter where you take a bite. If you can imagine a big, you ever go into those frozen yogurt places, or maybe Cold Stone ice cream, and you get the ice cream and you get all the little bits, and you take a bite, but it's different no matter where you take the bite. I might have 3 M&Ms here and a gummy worm over here. Okay, so that's a heterogeneous mixture. That's not the same through and through, that's different. Homogeneous is the same, just plain vanilla all the way through. Okay, and we talked about solvent and solute, which we'll talk about more later. Okay, great. So you guys are up to speed. You basically did like 2 weeks of college level chemistry, all right there. Check that out. Isn't that cool? So we talked about chemical and physical changes already. Remember we talked about how when you eat an apple, what happens? When you start to eat the apple, what's happening in your mouth? That apple is changing shape, right? So that's a physical change. What's happening though with the saliva? It's starting to break down the food. It's going to be part of a chemical change, remember? And then what happens when it hits the acids in your stomach? Also a chemical change. Okay, so we're going to take these ideas. That was like a 2-minute review, and we're going to take it a little bit further. Now we were starting to talk about matter. Now matter is going to be, here, let me move this up. Okay. Matter is made of only one kind of atom. So things that we talked about, elements, are just one thing, like just copper, just silver, just gold, just hydrogen, right? That's an element. And the periodic table has every element that we have ever discovered, whether they're naturally occurring or whether we make them in a laboratory. So an atom, this is the smallest part of an element that still has those chemical properties that make it what it is. So if you have a gold atom, you can split it into smaller parts, but it won't act chemically like it did when it was the whole atom, when it was the whole gold atom, okay? So what does that mean? Okay, so atoms are made out of 3 parts. Do you know what they are? Say them out loud if you do. Protons, neutrons, and electrons. Okay, so put out your hand and imagine like the planet Saturn. You got a ball in the middle and rings on the outside, right? Traditionally, that's how people think of atoms. It's not really right, but it helps in the beginning stages when you're starting to think about what atoms are, because they're so small. They're these fuzzy little dots that hold everything together and don't fly apart into pieces, and it's confusing because you can't see them. It's like electricity. You can't see that. You can see water flowing. So when we learn about electricity, we talk about water flow. So with atoms, we start to talk about things like Legos. So you can kind of visualize things you already have experience with. So an atom has the core, the center, and then it has this cloud around it. And in that cloud, you ever seen those old Wile E. Coyote Roadrunner cartoons? So the feet on the Roadrunner, they spin so fast, just like the spokes on a tire. It spins so fast you can't actually see them. It's just like this cloud. So that's what's happening with the electron on the outside. The electron is so fast and it zooms around, so it's just like this cloud. You can think of it that way. And inside is the proton and the neutron, and they're together. Okay, so the proton has a positive charge, a neutron has no charge, and the electron is the negative charge, right? Okay, so protons and neutrons are actually made of smaller bits that are made of smaller bits and smaller bits, but again, those aren't bits of state of matter. So atoms can have anywhere from 1 proton and 1 electron, that's what we call hydrogen, to over like 300. And it's the number of protons that determine what the thing is. So for example, in this one, do you see how it has a 30 up here? So that tells you how many protons are in there. So this is Zn, zinc, and it has number 30. That means it's number 30 on the periodic table, which is right there. It's a little fuzzy, sorry about that, but this is number 30. So that 30 refers to the number of protons. Now, if you change zinc into having only 29 protons, if you were to magically take 1 proton away, zinc would turn into copper. And if you were to change it again, it would turn into nickel. See? So just by changing the number of protons, you get a different element. So there are 30 protons in zinc, and this number down here, this is actually this is the weight of the atom, so you don't have to worry too much about this. It's called the mass number. It's the number you need to figure out how many neutrons are inside. So you could round this number down to 65. So now you'd have 65 minus 30. So there's 35 neutrons inside of zinc. Okay, so let's keep going here. Oh, no, if you change the number of protons, we get a different if you change the number of protons, you get a different atom, right? We just talked about that. If you change the number of electrons, that means that we can now get a charge on this thing. So now it's electrically charged. And we talked about plasma. So that's what's happening. Some of those atoms have gotten electrons knocked off of them, and now they're floating around and they're positively charged. So you have these negative electrons, positive charge atoms. So now you can electrically charge the atom by changing the electrons. Now, what happens if you change the neutrons? It's kind of a strange thing. It's a little bit beyond what we're going to talk about, but if you change the neutrons, you basically get what we call an isotope. It's the same element, but the number on it has changed. So it's a different form of the same thing. Okay, but it's a little more complicated. Here's what I want to show you. Have you ever done the baking soda and vinegar experiment? I bet you have. So does that reaction happen slow or fast? Fast, right? What do you see a lot of? Bubbles, right? So what are the 2 things you put together? Baking soda and vinegar. They are combining, which is they're combining chemically, and we call that a gas-forming exchange reaction. Don't worry about that part. But basically what's happening is you've got a solid and a liquid, and they're coming together, and now they're making gas. They're making carbon dioxide gas. We can write that down it looks like a kind of a math equation, like a strange math equation. So this is what vinegar looks like. So if you look, C stands for carbon, H stands for hydrogen, O stands for oxygen. So you see, that's vinegar when you put it together in this. So you got 2 carbons, 4 hydrogens, 2 oxygens. See, put those things together, you get vinegar. Baking soda looks a little different. See, here's the carbon, here's some oxygen. It has a different number of oxygens though, doesn't it? Look at that. And H is, what is it again? Say it out loud. Hydrogen. Na. Okay, that's sodium. Na. So we have sodium, hydrogen, carbon, and oxygen. So this thing together, this molecule is baking soda. So what happens is when you put these two things together, some of the O's break off, some of the H's break off, and some of the NA's break off, and then they recombine in certain ways. And by certain ways, you basically spend 4 years in college trying to figure out what those certain ways are. And then they will recombine. So notice this doesn't look anything like that, but there's one Na here and there's one Na here. So there's two COs here, and here's a third one over here. So there's 1, 2, 3 COs. So whatever happens on this side also happens in this. So when you put vinegar and baking soda together, you get sodium acetate, that's this molecule, H2O, you know that one, water, and carbon dioxide, those are the bubbles. So these are the three things. So this stuff is the white precipitate. It looks like it's a snow globe reaction forming. If you put baking soda and vinegar together and you're going to see it looks like it's starting to snow, that's sodium acetate that's being formed in there. And you have water and carbon dioxide. Isn't that cool? Now, if you were to take carbon dioxide, water, and sodium acetate and add energy, you could actually get it to shift this way. You'd wind up with baking soda and vinegar. Pretty cool, huh? Okay, so that's basically the essence of chemistry. We're taking those atoms, molecules, and we're rearranging them, and we're getting something else out. And the chemists have to be really good at observing what's going on. That's why we do a lot of chemistry experiments, because we want to hone our observational skills. Did it change color? Did it raise in temperature? Did it get colder? Did things crystallize, right? Did things suddenly, like this white powdery stuff just came out of nowhere with baking soda and vinegar? You should try that later. By the way, if you heat up the vinegar first, the reaction will happen faster. So we can adjust how fast reactions happen, which chemists also want to be able to do. And we'll talk about that actually more tomorrow. Okay, so I promised to teach you how to play with polymers, didn't I? Okay, so when you think of slugs and snails and puppy kisses, what texture do you imagine? Is it sticky, slithery, slippery? Any way you picture it, is it just kind of icky? That's because it's a polymer. Polymer is a plastic, and plastics are polymers, I should say. So imagine you're eating a plate of spaghetti. Just no sauce, noodles, right? Just plain noodles. Imagine she doesn't have any sauce on there. And the noodles initially, when you first take them out of the water and you stick them on a plate, do they clump together immediately, or they kind of slide? Yeah, they kind of slide, right? They slide all over together, right? So the molecules that make up the polymers, the things that make up slime and the bouncy balls we're about to do, they basically are long chains of molecules, really long, like longer than water, much longer. We call those polymers, and they basically slide around, they don't get tangled up. So the pasta by itself is like a long polymer, and it doesn't hold together until what happens? What do you have to do to clump your pasta together? Well, I know you have to wait, but if you couldn't wait till it cooled down and started to congeal, yeah, you put sauce on it, right? So the sauce is cross-linking. It's taking those long chains and cross-linking them into like a fishnet. And that's what's happening when you make slime. So for example, I don't have any glue, but if I had glue, that's a polymer. And if I have borax, that is your cross-linker. So you're taking both of them. So you don't have to use glue and you don't have to use borax. Those are just two that work. So there's a lot of different substitutes. So if you've ever done starch and water, that's really similar. Starch is very, very, well, starch is a little bit different, but so you can imagine how this is going to work. Let me show you this slide here. So we have these long polymer chains, and we're just going to add something to cross-link it together. So we call this a non-Newtonian fluid. You can basically fill, well, if you think about, like, I'll go back to the starch example. You know, if you've ever played with starch and water, you can actually get it to be a solid or a liquid or both at the same time. You can actually put like a water bottle, and it's a 2-to-1 ratio in there. So you want 2-to-1, so more cornstarch than water. So you put, a cup of cornstarch and half cup water, and you shake it up. And so those long molecular chains all get scrunched up together on impact. So when you hit it, and we actually will make huge tubs of these and ask the kid, we'll show the kids how it's a liquid, and we'll go really slow and we'll see it's a liquid. And then if they run across the puddle of cornstarch and water we made, it's actually a solid, because the impact of their feet will cause those chains to momentarily just get tangled up, and it'll actually act like a solid in that moment, which is pretty cool. Okay, so that's really easy. So if you rotate your bottle really slow with cornstarch and water, as long as it's in the right ratio, it'll act like a liquid. But if you were to throw it in the air or scrunch it or squeeze it or throw it on the ground and it doesn't break, you'll get a solid. So there's a lot of cool things a lot of cool properties, and that's why people like to use them. Okay, so how does this equate to a bouncy ball? How do we do that? Okay. So now if you were to go on and, let me show you that in just a second, because actually this I actually learned in college, which is pretty cool. If you go on to college and you take chemistry and you take organic chemistry, now organic doesn't mean pesticide free, it means it's the study of chemistry that has carbon in it. About 80% of your studies in organic chemistry is going to be in polymers. So if you're planning to be a chemical engineer, your chances of working with polymers are actually pretty high, because you'll find them in everywhere you look. The two main categories are natural and synthetic. Now, the ones that are synthetic, you can imagine, are like water bottles and foam and shoes and that kind of thing. Like most shoes are now made from polymers and synthetic. Natural polymers are like things like cellulose and DNA, that sort of thing. Okay, so what do we want to get from today's lesson? Well, the polymers we're about to play with are made of really small individual units, and those units are strung together in really long spaghetti chains, and we are going to make a polymer. You ready to make a bouncy ball? Okay, so here we go. Now, by the way, if you've just joined us, my name's Aurora with Supercharged Science. We are doing a chemistry lesson in atoms, and we talked about protons, electrons, neutrons, talking about polymers, and we are about to do an experiment. If you don't have materials, just take notes real quick. This is a super simple experiment to do. Nothing fancy. It is picky about ratios, so make sure that you're really clear on which one you're doing when. So I'm going to put my safety glasses on because I'm going to be working with my polymer. So the first thing, you're going to just need two ingredients. One of them is called sodium silicate. Now this, I don't remember where I got this from, thechemistrystore.com. I don't know if they still carry it. This was years ago. So sodium silicate you can get from a pharmacy. It's called water glass, and you can also, there's a link I think for a little $10 bottle. So you're going to need 4 tablespoons of sodium silicate. So let's go ahead and measure that out. So I've got my cup here, and I've got my tablespoon that I'm not going to use for anything other than chemistry, and I've got a disposable cup. I'm going to measure out 4 tablespoons. 1. Does it have to be perfect? No. 3, 4. It's okay if I slosh a little bit, just as long as you get about the right ratio. Okay. Always cap your chemicals when you're done. If this is your first time doing it, you can just use 2 tablespoons and just do a half recipe, and that's totally fine. So I've got my 4 tablespoons here. I'm going to use rubbing alcohol. This is ethyl alcohol. Isopropyl will not work. You have to use ethyl alcohol. Ethyl alcohol is also found in things like vodka. So yes, you can substitute that. And so that's something that's just for grown-ups, by the way. And this is different though, because this has other things mixed in so people don't drink it. Like things like gasoline, kerosene, and stuff is mixed up in this. So this is not something for kids to handle. So you want to make sure you do that. Notice I've still got my goggles and my gloves on. And I'm just going to start stirring, and I'll bring this closer so you can take a look. Okay. Do you notice a color change? I hope you do. Yeah, it was clear, and now it's white. By the way, try not to do this one next to a computer. Oh, you see how it's kind of gelling together? Almost there. Now, typically, you'll find sodium silicate is a preservative, meaning at the at the hardware store, they use it for sealing cement. And so if you were to touch this, I don't recommend it. If you were to touch this with your hands, the problem is that it will feel like you've got a snake skin over your hands after you come in contact with it. And so it's not a great feeling. It's really icky. So make sure you're using gloves. If you don't have gloves, stick your hands inside of some plastic bags, and that'll work just fine. Now notice what I'm doing. Notice how I'm slowly and firmly doing this over I've got a big metal tray under me that's just for chemistry. Okay, and firmly putting it together like this, and I'm compressing it, I'm squishing it, I'm getting all the remaining ethyl alcohol out of it. And when it's ready, it's almost ready. Okay, you can actually bounce it. Let me see if I can bounce it closer to you. You go, woo! So it bounces. When you bounce it, it breaks into bits like this. Okay, what you're going to do is put them, all the bits that you can get, slowly in your hand and firmly squeeze until you reform it. Okay, now this is not going to keep its shape overnight, so make sure you don't put this on carpet. You put it in a Ziploc bag when you're done, and in the morning you'll find that it's a flat pancake. That's because it's mostly a solid, but over time those spaghetti chains are going to relax and ooze back and kind of act like a liquid. They'll try to assume the shape of their container. There you go. And now you have a bouncy ball. And I actually didn't use all of it, so I have even more in here. So now I've got these ginormous bouncy balls. You can break them into smaller bits. You can't color these because they're not water soluble. Remember, we used alcohol, so you'd have to use an alcohol dye, and not a lot of people will have that. This is just kind of a single color bouncy ball for this one. So what do you think? Is that cool? Okay, so let me review what we did and give you a couple of other things. Then I'm going to show you some vampire veins, if I can get that working again. And I will show you that in just a second here. So what did we do? Well, we combined two things. We combined sodium silicate with ethyl alcohol, and it was a 4-to-1 ratio. It's 4 times as much of the expensive stuff and it is of the cheap stuff. So 4 sodium silicates to a ratio of 1 of the ethyl alcohol. And then you simply stir it around, and when you're done, you should have a bouncy ball. And you can store this in a Ziploc bag. You can also change the temperature of this by storing it in the fridge and seeing how that affects it. And this should keep for a couple of weeks, almost a month. Isn't that cool? So there you have it, fun with polymers, right? Okay, I'm gonna take my gloves off just for a second because I wanna show you a couple of things here. So how did that go? Okay, so take out your fingers, those of you who aren't messy, and put your fingers on the keyboard and tell me what's the thing that you really like from today's class. What'd you learn today? Okay, so while you're doing that, let me see if I can get, oh, now I'm just gonna have to put my gloves back on. Let me see if I can get vampire veins. Wasn't working well this morning before class, but let me see if maybe I can trick it into working. So a lot of kids love to make slime, and tomorrow's big class, do you see this URL here? You want to make sure you sign up for that. We're actually going to make, I'm going to teach you how to make glow-in-the-dark slime, and I'm also going to teach you how to make dinosaur toothpaste. That's all a part of it, and I'll send you a worksheet when you sign up. And that will happen tomorrow at 10 o'clock. This is not a Facebook Live class. You definitely have to sign up for that one. Okay, so let me see here. I haven't used this since Halloween, so it might be a little not working. Let me see. Yeah, looks like it's doing okay. All right, so let's see. So this is a bottle of, this is a polymer, and this is the cross-linker. Remember we talked about it? So this is not glue, and this is not borax. This is a different one. This one's called sodium alginate. And so right now we just have a clear liquid in here. And when I squirt it in, oh, there we go. And I can pull it out, and it looks like veins, doesn't it? It looks really gross, doesn't it? So they call these instaworms. They call them sodium alginate. Is basically the compound that's in here. Yeah, so these are real popular around, here, let me do it again. These are really popular around Halloween because they look really gross. Okay, so here, let me wash out my cup. This one is really, really picky, so I have to make sure there's nothing in my cup before we actually do it. Here, I'll do it again. Okay, let me take this out. All right, ready? Here we go. So what's happening? Well, part of the secret to this one is you need a squirt bottle. And as the liquid is squirting out, it's squirting out in a cylinder, and the walls of the cylinder react with what's in here and cross-link immediately. And so that gives you these really long chains here. So if I were just to plop it in and not squirt it in, it would actually just be more like a ball or like a lump. Kind of like that at the bottom. All right, where do you get something like that? You can look online for sodium alginate or Instaworms, I think they're called, or something like that. So that's really cool. This one in particular will shine green and red depending on where the light is coming from. So it has a certain molecule, a dye added in, that depending on which way the molecule's facing gives off a different frequency, a different color light. So when we shine this, it looks green to some people and red to others, and it looks really spooky. Okay, so again, that's another polymer. Okay, so where are we? So you guys put your 4-to-1 ratio in here, and hopefully you're noticing after you've made this, it really starts to harden up. And so you'll have to do some testing with this. Again, make sure that this is not near any pets or small children. And you don't want people touching this with their regular hands, at least. No, I just say ever, because there's some people that have sensitivity to sodium silicate. So make sure you have your gloves on. You can also change the size to see if that makes your ball bounce better. You can make a bunch of small ones. You can make a huge one. You can change the shape, hello geometry, and see if that works better. And see how perfectly round you can make it. All right, we should probably wrap it up for today. Tomorrow, just as a reminder, we're not going to be here. We are going to be at this URL, so make sure you register for that class so I can give you the worksheet and have everything all ready for you. Again, for tomorrow, if you don't have materials, it's no problem. Just like with today, just take notes as we go along so you know what to get once you're ready to do your experiment. And if you have any questions, oh, I forgot to check for questions. Okay, wait, let me check a few questions. Oh my goodness, a lot of them have come in by email. Okay, here, wait, let me check the Facebook ones first. Good, you guys saw that it was cloudy. How do you color it? Okay, we answered that. It's because it's based on alcohol and not water. You can't use food coloring. Well, you could try it, and then you'll see it just runs right off of it, just like oil and water don't mix. Okay, vampire veins. Yes, I just showed you that. I love how we do the bouncy ball. Okay, awesome. How do you sign in? Okay, so these classes are free. You don't have to sign in, you just show up. For tomorrow's class, you have to register here. And once you register, you will be given an email that has the link that you can click on to sign into that class. It's somewhere else. It's not on Facebook Live. On Friday, we'll be back here. Make sure your parents have saved their coffee for you. Not to drink, that came out wrong. Make sure that you've got some like old coffee and you put the grounds back in. You can put some grass clippings, something like that. Put that back in, because on Friday we're going to do water filtration. And so if you have the materials for that, it looks like carbon. This is activated carbon from a fish store. If you don't have that, but you have like charcoal briquettes, use that anyway. It'll still kind of sort of work. At least you get the sense of it. You'll also need pickling lime. This is optional, but it will help when we get to the sedimentation stage. You can do that one as well. And these are sold usually by grocery stores and stuff like that. So what else do I want to say? This, oh, by the way, sodium hydroxide is not something for kids to play with. The other thing, which I don't have a sample of, is alum, A-L-U-M, and it's in the spice section of grocery stores. There's also a link to it from the shopping list for this week. So you can take a look. So if you just want to watch that one, that's fine, because it's got some weird ingredients and you probably can substitute some things out. We'll talk about that on Friday. Next week is biology. We had a ton of people request biology classes, so we're going to do that next week. You will need to start your pond sample now. So if you know of anyone that's planning to, if you want to invite your friends to that class, totally do it. Make sure they know, though, they've got to get a cup. Not a cup with vampire veins in it, but a regular cup. And just go outside, grab a handful of grass with the dirt and stick it in your cup, put a little bit of water, put the top on, and put it in a warm, sunny window. And we're going to use that next week. You need it to kind of make this little bug soup because we need some critters that we need to look at when we're doing biology. So you're going to make your own little pond sample just like that. If you happen to have a place where you've got still water where it's easy for you to take a sample, you could just use that as well. Okay, I hope that's helpful. Make sure you register for class. I will see you in tomorrow's really big chemistry class. I hope you've enjoyed this. Make sure you do let other people know these classes are free. They're live, they're interactive, and I still have not answered all the questions, but that's okay. If you are not finding the link, you should go to superchargedscience.com/chemistry. It should be in the description. Here, let me see if I can type it in. Oh, no, it is in the description. You can just see it right there. You see where it says register for our big chemistry class, superchargedscience.com/chemistry. And when you click on that, it will load a page that apparently you can't be found. Okay, hang on. We're going to fix that. So give us about 10 minutes. We'll figure that out. Sorry about that. Thank you for letting us know. And if you don't have any supplies, again, it's not a problem, Angie. You can just participate and just learn along, right along with us. And when you do have the opportunity to get supplies, you can do that. Tomorrow, the supplies are really easy. It's, I think, yeast. So if you're used to making bread, it's already there. There's some soap. Just like a squirt of soap, some food coloring, and a highlighter. So if you have a yellow highlighter, take that out. If you have a little bit of glue, if you have some laundry soap, that's great. What else do you need? Hydrogen peroxide. If you have those things, great. If you don't worry. Just join us and just enjoy learning and with the class. Okay, I hope this has been helpful. I will see you guys all tomorrow. Enjoy your day. And oh my gosh, I almost completely forgot. On Saturday, we are actually having a chemistry scavenger hunt at 10 o'clock, and I'm going to put a post up about it. So if you've been doing these chemistry classes, you can have a lot of fun. We're going to play a chemistry game together. And so we'll be doing, it's kind of like a review of everything we've done this week, but it's in the form of a scavenger hunt. You'll be able to participate from your home. So that'll be really super fun. All right, I will see you guys tomorrow, next day. I almost said next week. I'll see you guys tomorrow. Take care, everybody. Bye.